So again, systems where there are two or more linear equations, two or more problems in the same set. And the answer to those problems is an intersection point or intersection shade if it's an inequality. We can solve for that ordered pair by either graphing it, substituting, and today we're learning the third way, which is elimination. The goal of elimination is to eliminate something. Yeah. Elimination means to get rid of, to remove one set of variables by combining like terms. So these equations have an x variable and a y variable. And there are two equations, right? The first equation and the second equation. And both equations have an x and a y because they're linear, they're on a graph. Our goal through elimination is to eliminate one set of variables. So to eliminate the x's or to eliminate the y's by combining like terms, meaning they've got to be opposites. In order for them to eliminate, if I have 5x in the first equation, the second equation has to have negative 5x because those are opposites. They eliminate. So, something to be aware of is that both equations are going to be in standard form. Oops, no squared. Both equations are going to be in standard form. If they're not in standard form, it's probably easier to substitute. If they're both in slope-intercept form, it's easier to substitute or graph, right? So there are kind of like paths that you can take depending on what the problems look like. But we're going to do like a smack you in the head, easy type of problem. Okay? So here's an easy type problem. Okay? If it's easy, you're going to combine like terms vertically. You're going to combine like terms vertically. Which way is vertical? Okay. Then you're going to solve for the variable. Then you're going to substitute the value into one problem and solve for the variable. Again, you're going to combine like terms vertically, up and down. You're going to solve for the variable, get an answer. Then you're going to substitute that value into one problem and solve for the variable again. Easy. The answer is an ordered pair. Right? For example, 4x plus 3y equals 10 And negative 4x plus 2y equals 5. This is a system. There are two equations. They're both in standard form, so I can eliminate. And the reason it's easy is because look at it. If I combine like terms vertically, my x's cancel out. I've eliminated it right off the bat. I eliminated my x's because they're inverses, they're opposites. They disappear when I combine them. I'm left with 5y equals 15. Combine like terms vertically. Did it, did it, did it. Yes? Solve for the variable. What does y equal? Substitute the value into one problem and solve for the variable. So I can take this value and I can put it into this top equation or the bottom. It doesn't matter. You pick. Well, let's do the top just because it doesn't have a negative. Might be easier. So 4x plus 3, but instead of y, I'm putting in 3 equals 10, yes? 4x plus 9 equals 10. Minus 9 minus 9, 4x equals 1. What does x equal? 1/4, 0.25. All of those are the same. The answer is an ordered pair, 0.25 or 1/4, comma, 3. It's elimination. Something eliminates. We combine like terms vertically. Cancel them out. Most of the time something's going to happen. Sometimes problems will be almost. Like sometimes you're like, oh, that's so close. Right? For example, negative 5x plus 7y equals negative 8. And 3x plus 7y equals 10. And you're like, oh man, that was so close, Mrs. Long. Oh, if only. If only what? If only one of these was a negative, right? Like, oh man. If only one of them was a negative. But guess what? You can make it. You can change all values to positive or negative. All of them in a problem. It's like multiplying by -1. Hey. I can change everything. I can change everything. Do you want to change the top or the bottom?
Top.
Change the...
It's got a negative.
It doesn't matter, right? I can do either. I can change the top. Everything gets changed. This becomes positive. This becomes negative. And this becomes positive. If I changed the bottom, negative, negative, negative. And the top would have remained the same. It doesn't matter. But now that I've changed everything, I combine vertically. That's now positive 5x plus 3x because it's positive, right? Is 8x.
Yep.
My y's cancel out. And I get 18. And then you can continue to solve. Solve for the variable, substitute that number into one of the original problems. It doesn't matter which one. And you solve. Pretty straightforward? Okay. So now let's talk more difficult.
Difficult version.
Okay, so a little bit harder.
The hard version.
Challenge. Let's go with challenge as opposed to hard. Let's go with the challenges.
Level challenge.
Yep. Leveled up. So So the challenging problems that require just a little bit more thinking. Are challenge problems. You're going to have to, on a challenge problem, you're going to have to multiply one or both equations to create to create, what do I want to say? To create inverses. That's what I want. Opposites. And sometimes you only have to do one, and I really like those problems. Sometimes you have to do both of them, and that's okay. Here's my advice. If you go the one route, one problem. If you go the one problem route, it's because they are multiples. Like if you have one problem has 3x and the other problem has 9x, is 9 and 3, can you multiply something to get here? Yes. If you had, 5x and 35x, right? I could do something to 5 to make it into 35. If you had 2x and 14x, right? Multiple. We're looking for multiples. If you can't find multiples easily, and you have to do both equations or problems, I suggest multiply the top by the bottom, x, and multiply the bottom by the top, x. And I'll show you what that means. I'll show you what it means. But our goal is to just get things to cancel out. I want inverses to be happening. So sometimes you have to multiply one or both of them to create opposites. If it's one problem, you need to look for multiples. If it's both problems, I suggest you just go straight for multiply the top by the bottom x coefficient and bottom by the top x coefficient. And we're going to practice. And remember, always, always, always remember, you can change all the values in one of the equations, but you have to change every single value. A positive becomes a negative. The negative becomes a positive. All the way through the problem. That's multiplying by -1. And if you do the same thing to everything, that's okay. All right, so let's start off just having to change one.
I guess we're doing the hard one.
This can be solved either way. If you say, Mrs. Long, I'm not really good at multiples, right? You could do both of them. Let's pretend that there isn't a multiple. I could multiply this top equation by the bottom x coefficient. This entire top equation could get multiplied by 2. And this bottom equation could get multiplied by 4. I could do this every single time and it would work. Or look for multiples. Is there something in here that's multiples? Something that if I did something to one, it would make it into the other? Landon.
4x and 2x.
Yeah, 4x and 2x. If I took this guy and multiplied it by 2, would it cancel out or have the potential to cancel out? So I can multiply this by 2, making my new problem 4x plus 2y equals 8. The first equation did not change.
No, not 2y.
What does this equation become?
4x plus 10y.
Okay. And I'm really close to canceling, right?
Yeah, you just need to turn everything.
I could change everything down here into negatives. Oh, and this becomes a... Or could you keep that the same and change the top? Doesn't matter.
Doesn't matter.
So this now becomes... Oh, that cancels out. What's 2y minus 10y? Negative 8y. Equals... What's 8 plus 4? 12. Y equals what? Negative 1.5, negative 1.5. Because I did 12 divided by negative 8, correct? I can now take this problem and I can put it into this equation. I could put it into this equation or this equation. It does not matter which equation I put it into. Any equation. I'm going to pick the top one. 4x plus 2 times negative 1.5. Instead of y, I put negative 1.5 equals 8. 4x, what? What's 2 times negative 1.5? Negative 3 equals 8. 4x equals 11. X equals what? 2.75. Beautiful. See why we're not graphing this? Do you want to graph?
Yes, kinda.
So my answer, 2.75, comma, negative 1.5. Yes? Let's try a both problem. Yes, ma'am.
Okay, so when you're substituting, or not, so when you're putting 1.5
Mm-hmm.
into one of the original columns,
Okay.
say we chose the second column.
You'd get the same answer.
Okay, but would we do it before we multiplied by 2?
Doesn't matter. You could put it into this. You could put it into this. You could put it into this one, which is the same. You could put it into this one when it was all positive and negative, right? Or you could put it into the second version of it. Does not matter which one you pick. It will give you the same solution. If your math is good.
I hope your math's good.
So what about 3x minus 4y equals 7 and 2x plus 5y equals negative 10. I don't have multiples in this problem. Do you agree with that? I mean, 2 and 3, that doesn't, I can't multiply 2 by a whole number to get 3. I can't multiply 4 by a whole number to get 5. Like, I don't have a multiple to get there. So I have to take the top and multiply the bottom. That's too close in color. Multiply by 2, right? And the bottom is going to get multiplied by the top, correct? Which is 3. I'm picking the x values. If you're partial to the variable y, you could go with y. Doesn't matter. I just tend to go with x first because it just is the first number I see. So what does my new top equation become? And what does my bottom equation become?
Ooh. We can make it negative.
Now nothing cancels out yet. Now I guess if I would have gone and multiplied the top equation by 5 and the bottom equation by 4, it would have canceled out, right? Doesn't matter. I mean, it's just one more move. What should I move?
Make one, either the top or bottom.
I can change either all of the top or all of the bottom. Let's do top just for fun this time. Yep. So then cancels out. 8 plus 15 is 23y. Yes? Equals negative 44. I'm going to have, let's leave this exact. I think it's going to need to stay, maybe not, as a fraction. What does y equal? Negative 44 divided by 23. Not one I know off the top of my head.
It's less than 2.
Is it big?
Yes.
Give me, so I'm just going to leave it as a fraction. Negative 44 over 23. Is that the same thing?
Yes.
I mean, that's just an easier way of writing the problem instead of rounding a decimal, right? All of that stuff. In fact, this is even better sometimes because now I can take this and I can substitute easily because it's not a decimal. Does that make sense? I can substitute into either of these or this guy or this guy. It does not matter. All of them, if I do my math right, will get me the same solution. Let's do this guy. 2x, plus 5, and instead of y, I'm going to substitute negative 44 23rds equals negative 10. On your homework, you're going to have whole numbers. I made sure on your first day
It's not like
we weren't dealing with
negative 132
Yeah.
over
No decimals.
crazy numbers. So 5 times negative 44 over 23, right?
20 over 23.
You.
Yep, big.
I mean, it's okay. I can do it. I believe in myself. Negative 220 over 23 equals negative 10, right?
Yay.
I mean, it works. It's not pretty, but it works. I add 220 over 23. So that means negative 10 plus 220 over 23, right? Negative 10 23rds. Then I'm going to divide by 2. Negative 5 23rds. So my solution is negative 5 23rds, comma, negative 44 23rds.
Really big number.
But again, you'd have to solve this one by elimination, right? Like you could not graph this. I guess you could substitute if you wanted to change one of them to y equals mx plus b, but I feel like that's just as much work as this. Again, to start out with today, we will just have pretty little numbers that we see.
numbers.
Cute little numbers.
It's just the number that you ever